Alright, so today we're going to learn how to do a really special case for multiplication, mainly multiplication of binomials. That means there's two pieces being raised to a power. It's really cool. I'm going to first show you why we need it. Alright, if we had x plus 1 to the fourth power, multiplication is not going to be fun. That would be this, by the way, is the same thing as x plus 1 times x plus 1 times x plus 1 times x plus 1. Alright, and if I was going to do that, I would multiply these two together first. Alright, x plus 1 times x plus 1. I can stack and multiply, or I can distribute. This time I'm going to distribute. Right, x to both is x squared plus x. 1 to both is plus x, and 1 times 1 is 1, which is going to give me x squared plus 2x plus 1. That guy's there. This one I'm going to stack and multiply just so you can see it. Move him down here. Multiply 1 times 1 is 1. 1 times that is x. X times 1, put 1 0. X times 1 is x, and x times x is x squared. Draw my line and add x squared plus 2x plus 1. And now I have to multiply these two things. I'm going to distribute this time, but I could have easily just stacked. I'm going to send x squared to each of these guys. X squared times x squared is x to the fourth. X squared times 2x is plus 2x cubed. X squared times 1 is x squared. Now take 2x times x squared, and that's going to be plus 2x cubed. 2x times 2x is 4x squared, and 2x times 1 is 2x. Hold on, we're not even done yet. 1 times x squared is x squared. 1 times 2x is 2x, and 1 times 1 is 1. Now I get to add all my like terms together. There's only one x to the fourth, right there. 2x cubed is here. There's another 2x cubed there, so that becomes 4x cubed. There's an x squared here, and a 4x squared there. That's 5x squared. And another x squared here. That's 6x squared. Alright. Used. I have a 2x here and another 2x here. That's 4x. And there's a 1 plus 1. So all of that work is to get x to the fourth, x plus 1 to the fourth, multiplied out. Now, this really cool guy way back in like ancient Greece, I think he was Greek, yeah, named Pascal, came up with a triangle that does all of this multiplication way faster. And he saw that when you're taking powers, actually this thing has applications all over the place, but it works first for you guys with binomial being raised to lots of powers. He found a really cool pattern, and that is if I had x plus 1 to the 0th power, anything to the 0th power is 1. Let's put this right. Alright? And if he had x plus 1 to the first power, he found the coefficients, the numbers in front, would be a 1 and a 1. And then he found that he can expand it. When I square it, x plus 1 squared, the numbers in front would be a 1, and then it would be a 2, and then it would be a 1. And if I just keep bringing 1s out here and adding these two numbers, they'll give me a 3, and adding these two numbers will get me a 3, and then bringing this 1 down here, he'd eventually have the coefficients of x plus 1 to whatever power I wanted. Alright, watch, we'll just keep going. That's a 1, that's a 4, that's a 6, because 3 plus 3 is 6, 3 plus 1 is 4, and a 1 on the end. And then he has a 1, and 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and then a 1 on the end. And found that this actually works all the way down to whatever power I need. the second numbers, this is the second power. Tell me what power I'm on. This is the first power, second power, third power, fourth power, fifth power line. So watch, if I had x plus 1 to the fourth, that's this line right here, right? By the way, this triangle, if we ever get back into my classroom, I have a poster that has them all in circles, and I think I built my triangle down to like the 7th or 8th power, something crazy like that. We're not there now, so you might want to write this triangle down somewhere. You can keep going as deep as you want. I don't think we're ever getting anything past the 5, but we might, who knows. It's not hard to build. So watch, I'll show you how to use this. My fourth line, 1, 2, 3, fourth line, has 1, 4, 6, 4, 1. So I would know that my first coefficient's a 1, second one's a 4, third one's a 6, then a 4, and then a 1. I take this guy, my first number, and start at my largest power and count down. So this would be x to the fourth, x to the third, x to the second, x to the first, no x, which is x to the 0th. Then I take this guy and raise him from this power, from the bottom up, counting down. So this would be 1 to the fourth, 1 to the third, 1 to the second, 1 to the first, and no 1. And just add those pieces up. All right? 1x to the fourth. It's just x to the fourth. 1 times 4 is 4. 4x to the third. 1 times 6 is 6, x squared. And 1 times 4 is just 1 times 4 with an x. It's just 4x. And then 1 to the fourth is just 1 times another 1 is just 1. And now I have that. Might not sound super great, crazy, whatever, but let's show you how I can do this. So let's say that that's not a 1. Let's say x plus 2. That's not so bad. And let's raise it to the 5th power. All right, you can go ahead, pause the video, and multiply it out. You will take up the whole page to get down to this answer. All right, I would look and say, okay, let me build my triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, because it's the 5th power. You'll notice all I'm doing is looking in between the two numbers above where I'm trying to find and add those together. All right, so this is my line. So I take my coefficients, 1, 5, 10, 10, 5, 1. I'm going to go backwards a little bit here just to make my numbers separate, and I'm going to change colors on you. So I'm going to have 2 to the 5th counting up. So times 2 to the 5th, times 2 to the 4th, times 2 to the 3rd, times 2 to the 2nd, times 2 to the 1st, times no 2. And then I take my x's, x to the 5th, and count down. X to the 5th, x to the 4th, x to the 3rd. By the way, I'm only working this out slowly right now because this is our first time. As you get better, you're going to get faster and faster at this. X to the 2nd, x to the 1st, no x. And I just bring out all my pieces. So the first one, I'm going to have x to the 5th plus 5 times 2 is 10, x to the 4th. 2 squared is 4 times 10 is 40, x cubed. 2 to the 3rd power, again, posters on my wall, but not in my wall, is 8 times 10 is 80, x squared. 2 to the 4th is 16 times 5 is 64, what's 80, right? Plus 80x, and 2 to the 5th is 32. Again, way easier if you see the posters on my wall that have all this. And that's it. I would already have it worked out. Now, if you don't believe me, and you want to say, oh, wait a minute, why is he doing that? If I didn't have this, Oh, I just moved everything. If I didn't have this, if I just had that and I tried multiplying it out, I'm going to stack and multiply this time so my terms line up. I have x plus 2 times x plus 2. 2 times 2 is 4. 2 times x is 2x. 0, x is 2x. X times x is x squared. And I have 4 plus, that's 4x plus x squared. Alright, now I've multiplied it once, twice, 3 times, so x plus 2. 2 times 4 is 8. 2 times 4x is 8x. 2 times x squared is 2x squared. 0. X times 4 is 4x. X times 4x is 4x squared. And x times that is x cubed. Hopefully by this time you're already saying it was faster doing the triangle. It was. Add down, I have 8. Now I have 12x. Now I have 6x squared and an x cubed. Now I'm done it 1, 2, 3 times. Do it a 4th time. I'm going to run out of space. I'm going to bring it up here. X cubed. Remember, that is going to be our answer that we did through the triangle. Plus 6x squared plus 12x plus 8 times another x plus 2. I'm going to make a mark of this. 1, 2, 3. We've only done it 3 times. This is going to be number 4. So we're still not going to be done. 2 times 8 is 16. 2 times 12x is 24x. 2 times 6x squared is 12x squared. 2 times x cubed is 2x cubed. Put my 0. X times 8 is 8x. X times that is 12x squared. X times this is 6x cubed. And x times 1 here is x to the 4th. Draw a line. By the way, you might notice that we're getting all this. Okay, we'll leave it alone. You're getting all the coefficients along the way. 16, that is 32. This is 24x squared. And this is 8x cubed. And this is x to the 4th. Done it 4 times, now we do it one more time. X plus 2, so we can finally get our answers that we already had from the Pascal's triangle. 2 times 16 is 32. Hey, that looks nice. 2 times 32x is 64x. 2 times 24x squared is 48x squared. And 2 times 8 is 16x cubed. 2 times x to the 4th is just 2x to the 4th. Put a 0. X times 16 is 16x. X times 32 is 32x squared. X times 24x squared is 24x cubed. By the way, some of you are going to see the advantage of stacking and multiplying now. See all my like terms are lining up? Doesn't happen in distribution in larger powers. Lost my spot. X times that is 8x to the 4th. Let's not get into there. X times that is x to the 5th. And if I draw my line down, I now have x to the 5th. Check. Plus 2 plus 8 is 10. X to the 4th. Check. Plus 16 and 24 is 40. X cubed. Yay. That's 70 and 10 is 80 x squared. Yay. 80 x. Yay. Plus 32. So all of this work could have just been using the triangle, seeing that, multiplying the pieces, and going straight to the answer. We're going to do one more, even though this is a long video, one more just to kind of show you, because this is the only big deal we have. And the math is going to be fairly nice. Let's not do the 5th power because we already have it. Let's do something ugly. The 7th power. X minus 1 to the 7th power. Now, you know already multiplication, doing this by the steps, one number at a time, is going to take forever. I'm not going to do that. I'm going to try to get this done in less than 5 minutes. I'm going to have 1, 1, 1, 1. 1 plus 1 is 2. 1, 1. See here? I just add 1 plus 2 is 3. 2 plus 1 is 3. And a 1 on the end. I just keep bringing ones on the ends. Basically, it's 1 plus 0. But 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. And we're 7th power, right? 1, 7, 21, 35, 35, 21, 7, 1. Alright? So, I have this line right here. That's my 7th power line. Alright? And I'm going to have 1, 7, 21, 35. I actually usually do this faster, but I'm going to try to write it out so you see where everything goes. I start with negative 1 to the 7th. Negative 1 to the 7th power is an odd number of negative 1s. It's just going to be negative 1. Negative 1 to the 6th power, that's an even number of negatives. That's going to multiply to just 1. This is going to be negative 1. This is going to be 1. Watch, it's going to fit a pattern. Negative 1, 1, negative 1. Because this is an odd power, even power, odd power, even power, odd power, even power, odd power. So it's the 7th, the 6th, the 5th, the 4th, the 3rd, the 2nd, the 1st, no 1. Alright? And now I just have x's. X to the 7th, they count the other way. X to the 6th, X to the 5th, X to the 4th, my tip's getting dull, X to the 3rd, X to the 2nd, X to the 1st, no X. So that, which was going to be an ugly math problem, is now just X to the 7th, that's going to be a minus 7, X to the 6th, 21 plus 21, X to the 5th, minus 35, X to the 4th, plus 35, X to the 3rd, minus 21, X squared, plus 7, X, and I'm going to run out of room, minus 1. Can you see? Oh, I get cut off. Minus 1. I guess I could just scoot my board over. That's an X minus 1. Alright? And play with the powers. It's going to start rough. As you get the hang of it, it gets better and better. That's the only thing we're doing today is just expanding binomials to larger powers. You can multiply it first if you want. I'm going to let you know you're going to get miserable fast if you keep trying to multiply. Pascal's triangle is really kind of fun. Try things out, multiply, play with it. And it's going to end up turning into a fast shortcut. The more you practice this, the faster you get with it. There's lots of patterns to see in here. Alright, even down here with these negatives and the signs that end up popping up, lots of patterns to see. You are more than welcome to explore, see if you figure out the patterns. If you don't figure out the patterns, it's never going to get any worse than finding the line in your triangle, doing the problems, and writing it out. This is now the long way, and you can even go longer and multiply things out one step at a time. But you will hate math, and me, and you. Don't do that. Try the triangle. Fun with it. It's a fun multiplying shortcut. Still hoping I'll see you soon. I miss having you guys in class.